Okay, Year 12. Welcome to today's podcast, screencast on the cumulative distribution function. Right, it's the CDF for a probability density function. Wow, this is pretty intense language. And we're going to do some calculation of probabilities. Let me explain the idea behind what we're going to do today. We're going to look at, you know what cumulative is. It's up to a point, right? So if we're looking at what we're going to be faced with, we're going to be looking at probability distribution functions between values, between endpoints B and A, perhaps, where that we know that the integral here between B and A of this function, if this is defined by y equals fx, then we know that this integral will equal 1. Well, what we're going to look at in this lesson is we're going to look at finding out what the cumulative distribution function is. So what that means is we're going to find out for a point x between B and A, we're going to find out what the CDF is. So we're going to be finding out what the area is leading up to from a point A to a point X. So we're going to be looking at finding out this integral, if you like, between x and a. That's going to be our cumulative distribution function, and we're going to do it in a curious way. We're going to find it, and f is our capital F is our letter, our symbol, of a cumulative distribution function. And x is our random variable. So the cumulative distribution function for x being less than or equal to this value of x, right? That's going to be equal to the integral between x and a of. This is where things get a bit fruity. We're going to turn everything into some other variable, right? So I'll show you an example. It'll make sense. It'll be ft dt. Now this is for values of x between a and b, right? So just bear with me for a minute. The idea is that we're going to find the cumulative distribution function, so essentially this area in here. That's what I want you to be thinking about for a point x anywhere between b and a. Now, what that's going to enable us to do is to work out probabilities. Now, the probabilities, remember, with a cumulative distribution function, the probability is the area. We don't find probabilities of distinct values. In fact, we can't. We just find probabilities of a range, for a range of values. So that's what we're going to be concerned with here. Okay, so let's just take a look at the first example. All right, so let's have a look at an example here. Okay, so here's an example. A continuous random variable x, capital X, has PDF, probability distribution function, density function, given by this here, f of x equals x squared plus x, k over x squared plus x, for between 1 and 2. What that means is that between 1 and 2 of this function, k over x squared plus x, this is going to be equal to 1. So I've got to find the value of k that solves this. So we get our calculators out. If you remember, we go to menu 3, 1, put in an n solve, a numerical solve, and find out what k is. Now, put that through your calculators, do a practice on that. You should get k is equal to 3.4761. K is equal to 3.4761. That's by GDC. No different to what we did the other day, so I'm not going to bring the calculator up and show you that. But what I want to do is the second part of this question. So for that value of k, this is a valid probability density function. Now I want to find the probability that x lies between 1 and 1.75. So this is where this section of work comes into its own. So if I don't know what this thing looks like, but let's say it's doing something like this, and we're looking between the whole thing is defined between 2 and 1, and that area is equal to 1. But I want to know what the probability that x lies between 1 and 1.75 is, right? So I'm bringing in a 1.75 here, and I want to know what that probability there is. 1.75. So what I'm going to do is I'm going to bring in my cumulative distribution function and find out what value, what this area in here is. And so to calculate that area in there, it's simply a matter of saying that this area, right, that area in there, that area is equal to, what is it, between 1 and 1.75 of 3.4761, whatever k comes to. Use the whole calculator to display over x squared plus x dx. And that will get you 0.838. I think if you just pop that into your calculator, 0.838. Okay, so that's just dealing with just the idea of finding a probability using area. Now we're going to go and find some cumulative distribution functions to help us with this process of finding the area. Okay, so now next example, we're just going to look at now, we're looking at a function, a probability density function defined by 1 plus cos x on pi. Now, between 0 and pi, this has an area of 1 plus cos x over pi. Okay, so you can see I've just drawn this on Desmos. Here's pi right here at the x-intercept. So my area between 0 and pi, this area here, is equal to 1. What we want to do is find the probability that our random variable lies between two values, pi on 2, which is in here somewhere, and pi on 6. So we're going to find an area beneath this curve, remembering our sample space is 1. So let's get back to our notes. So if we replicated that, so this is roughly our function here, y equals fx. Okay, just for visuals. Now, so find an expression for the cumulative distribution function of x. So here we go. What we're essentially going to do is we're going to find a function of x that, the cumulative function, which is going to give us the probability up to a value of x, somewhere between 0 and pi. All right, it's going to take us, some arbitrary value here of x. So essentially what we end up doing is we're finding this function f, which is x is less than or equal to x. Now this is going to be, right, so it's going to be between x and 0 in this case, 0, of f of t to t. All right, just bear with me. All right, you'll see how it plays out, because what x is going to come back into it, f of t. So we're just replacing our x's with t's. So we end up with 1 plus cos t over pi dt. Let's do a little integrating here, get maybe the pi out the way, so that we have our 1 goes to, we're in terms of t, so it's t. Cos t goes on integration, goes straight back to sine t. And we're between x and 0. So we have 1 over pi, right, so we have x plus sine x minus 0 plus sine 0, which I think all comes to 0. So we're just left with 1 over pi x plus sine x. And now that is my cumulative distribution function. So what that means is I can plug in now a value of x, and I'll get the probability up to that value from 0. So that gets me this area in here for some value of x. Now if I want the probability that x lies between pi on 6 and pi on 2, then effectively what I'm doing is I'm taking, so therefore the probability that x lies between these two values, I think, sorry, it's the other way around, pi on 6 here. That's going to equal my f function, my cumulative, my CDF, at pi on 2 minus my f function at pi on 6. Now, the beauty is that I've found a function here now that I can just plug values into. So, my f value at pi on 2 is just 1 on pi on 2 plus sine pi on 2, which is 1, minus my f function at pi on 6 is just 1 on pi pi on 6 plus, now sine pi on 6, do a quick triangle here, sine pi on 6 is there, so that's a half. So remember, I'm subtracting all of this here. I've got 1 on pi by pi on 2, so that's 1 over 2 plus 1 over pi. That gets me that result. Now I'm subtracting this here, which is 1 over 6. Once I've cancelled that out, plus 1 over 2 pi. That's subtracting all of that. Okay, so it looks like to me I'm going to have a denominator of 12 pi here. So I'm going to get 6 pi plus 12 over 12 pi minus, and what have I got here? I've got 2 pi plus 6 over 12 pi. So when I put all this together, I get 4 pi. I've got 12 minus 6 plus 6 over 12 pi. Dividing through by 2, I get 2 pi plus 3 over 6 pi. And I think that will be my result. Okay, so I think now we can do questions 2, 4, and 6 from exercise 10K. And then our next stop after this is the normal distribution. Okay, but let's have a look at these 3 questions in today's lesson. Cheers.